record this for the people in the lab. So if you need another refresher, it should be up later tonight and on the YouTube and posted on TV website. Hopefully it'll work. Hopefully I'll get it up tonight. Let's do it that way.
That's what she said.
Yeah. It all depends on my ISP and everything getting uploaded fast enough. Things beyond my control. So. What? That was really funny with him. We're not even telling April Fool's jokes he's still going off over here.
I'll tell you afterwards.
Okay.
It's dirty.
Oh, okay. Never mind that. Better not record that. Oh, there's that out here. I'll tell people signing up for this class next time. All right. Anyway, we'll start off with remember how we had been doing things, and those that are in my lab and what we've been talking about before, putting a lot of things into arrays to keep up with all the different data parts. So if we were doing, I'll break this out again. Do you see it? In the lab, we're keeping up with like the UPC of an item and its price, and its description, and to do that, we had several different arrays going on. Right now, I think you only have 2 arrays. We added a 3rd data element this past week. What did we add to it besides the quantity on hand? That's what we had added. So how many do you have in your inventory right now, so you can update it. Then we had all these into different arrays, and those were parallel arrays, meaning that data is spread over all the different arrays, but to access like item number 3, index number 3 on it, you go to UPC number 3, price number 3, description number 3. Now, from this, what's actually going on in memory here with that is you've got UPC set up in memory. Here's this big chunk of memory with all the different UPC numbers in it. And over here somewhere in memory is the price. And somewhere else over here is the quantity on hand. Over here somewhere is the description, which all of these will be individual strings. So an array of char arrays, so a 2-dimensional array, something to get with our description, something that you'll be adding to lab this week. And the things, you keep having these different memory chunks all over the place that you're using with it, and keeping up with what all they are out there. I'll show you something new today. Instead of using just an int, or a float, or a char, we're going to create our own data type. And that data type, in this case, can have an int, a float, and a char array, or a string, all as part of that one data type. That's called a complex data type, or a struct. That is going to be our keyword here for it. You got 2 new keywords, type def, and you'll figure out what that means. You're defining a new type, a new data type. A struct is a structured data type. More than one part you're going to build upon with it. And right here's the syntax for doing that. So type def struct, give me a new data type that I'm going to define myself, user-defined data type, struct. Within here, then you list your different parts that you want, what they are, and what you're going to call them. And then this here is the name of the new structure, your new data type. This is now a new data type called item. And so I can create whatever I want to of different items, each item of which will have its own UPC, price, and description, and any other attributes we want to add to that. There they will be. And from Wikipedia, we get the definition of a struct here, a complex data type declaration that defines a physically grouped list of variables to be placed under one name in a block of memory, allowing different variables to be accessed via a single reference. So instead of UPC over here, price over here, the quantity over here, and description over here, we have one block for an item which has this UPC, this price, this description, this quantity, whatever, all right there. So anything you want to know about that item, there he is, one chunk of memory. A little bit more organized with that. A struct can contain many other complex and simple data types in an association, so it is a natural organizing type for records like the mixed data types in lists of directory entries, reading a hard drive. So you want to keep stuff together is a good logical way to do it, just like you would do it for real. You're going to structure it in memory the same way. Things like keeping up with things on the hard drive, like the file length, the file name, the file extension, the physical location of the file on the hard drive. You can create one structure that keeps all that data in one block. Or mixed record types. Like here we got patient information for a hospital thing, or a doctor's office. We got patient names, their address, their telephone number, their insurance codes, balance, whatever. Keep the records of that person on hand in a struct. All right. Now we're going to declare a new guy this way. See, we don't have to go declare what an int is. We don't have to declare what a float is. But since it's a special one that we're creating, we've got to tell it what it is first. After we've declared it, now we can go off and create variables of that data type, just like we would anyone else. Like you'd have float price, we've got an item inventory. So here's a variable of type item that we're going to call inventory. So that is the name of the variable of data type item. That make sense? That's giving you the power to go out there and create anything based off of other stuff that already exists now. Now, how in the world do you get to that data? All right. Once again, we've got data type item, which is called inventory. So that is the name of our variable. It has the different members called UPC. He has his price and description. To get to them, you need to set the UPC or set the price or read the price, whatever it is. Well, to get to it, you just reference it by the name of the variable, in this case inventory, and put a dot to get to the member inside, price. So you want inventory's price. You can have other variables of this type as well. And so you're just saying which one's price you want to get to. By using his name dot price. And, or inventory dot UPC, whatever in this case. And use it for comparisons just like you would anywhere else. If you're just comparing UPC, and you remember go through a loop trying to find which one has what we want, kind of things. If that inventory's UPC equals input UPC, hey, you found the right guy, kind of things.
Did you do item inventory as an array?
We're getting to that. Yeah. That's actually our very next thing. Good lead in. So you think like I do. Oh no, that's scary. Maybe for both of us. So yeah, just like any other data type, we can create an array out of it as well. And now this time when we're creating an array, it's going to set aside this much room for each element of the array. Each one of these now will have its own UPC price description. UPC price description. UPC price description. Right there with it. So, like our example here, item inventory 20. What's that going to do for us?
20 items.
20 items, correct. Numbered 0 through 19. Remember that part. To access the information for element number 3, not the third element, but element number 3, inventory sub 3 .upc. Notice where you're putting your index. It is inventory, in this case, that is the array. And so you want to access either 0, 1, 2, 3 of inventory, get down to him, and then get to his price, or get to his UPC. So you got to figure out which one first. So he goes, that part goes with him. And then access the individual member of that element's information. Questions on any of that? We're going to get to play with this a little bit in a few minutes, so it'll drive it in better. Now, we can make this as complex as you want as well. We can declare a data type, an item, line item. See, in this case, we'd have a line item if we went up here and created, actually, item's not really the best thing to call him. Actually, we just need to add some more information in there with him. If we're tracking an individual item for a sale, we can do a type def. Let me move this over. Back over here. Type def struct. That's not quite right. Open bracket. What do we need for a single line? We need to know the quantity that we just purchased. And then we need to know the UPC and the price, and whatever else. Well, we already had the actually item that will do that with UPC and price there, so we have an item. So, wait. Int quantity. Item. Like, just the hard part is creating your variable names too. Because what do you name it? What do you name it? And I can't call it item because that's the data type. Purchase. How's that? Purchase is the name of our item from inventory over here. All right. I can have a float ext price. And that should be good. I'm going to call that is a line. All right. So I've got we need to have a structure called inventory. His structure is, that's the item. Okay. It's got our UPC price description. We have a line that will have the quantity our UPC and price, and our extended price, and then we can have our wholesale. So we'll type def. Struct. And we'll have our float subtotal. Float tax. Float total. Num items. So our total number of items. Oh, now you can also do something keeping a date, anything else that you need to know about a receipt, all that kind of stuff in here. And then we'll also have okay, call him line. We want line item. So 100. Quote on a receipt. All right, so this is what our receipt looks like. If we go out there and create him, we've got our total, tax, subtotal, number of items, and what's here? Up to 100 lines that we're going to let them purchase. And this is where we can come in and say 15 of cans of soup at $1.50 each. Because he is one of these where this, this is an array of these. See how complex you can get this? All the way down, but it's what it's going to do is because it's going to set this all up once again in memory. We've got all this part, of which part of that is of that, which is some of these things. We'd be in an array, so you can see how it's going to store it all in memory, all together. Confused enough yet? Any questions on it? Some people might just have to watch the video to catch back up. All right. Now, here's the fun part. We have, we come up, we create an array now. We're declaring a variable named sales as an array of type receipt. 100 of them. So we're going to have set up 100 sales receipts over here of this type. I showed you how to get to some of those guys. Remember here, inventory, third item of inventory, you get to his part. If I was wanting to get to the first receipt's third line item's price, I set it to 325. How would I reference that? This is some of the parts you might see on the test concerning this. So, we've got sales is the big array, right? We want to get to the first receipt. So, what's going to be the first receipt in the array? about sales sub-zero, and this is your first receipt. Now we want to get to his third line item's price. All right. From here, we've got the line item. So we want the third one's price. So line item is an array. Correct. We are going to the second one of those. Dot. Well, he's of type line, which line is one of these.
For dot purchase.
Yeah, in this case we're going to have dot purchase,
Dot price.
dot price. The C is made up of these. See, that's about as complex as you'll ever get in one of these. They're not normally only going to stop about here and how you define them. I created one pretty complex just to show you how bad it can be. So, and then from there we just say equals 3.25. That's how we set his line item's price of $3.25. Questions? Did we get lost in that? All right. This is before I redid my structure here on the fly. So we gave another level in. While this shows just price, that's based off what's written in here before I created new levels of things. How we recreated with the purchase in here as well. All right. So together we're going to create a phone book. So let me give us a little freeboard here. See, at first we did call this a complex data type. All right, so let's look at doing a phone book program, let's say for your iPhone or your iPad, Droid device, whatever. It's going to store the data that you put into it somewhere, right? And guess what? It doesn't have the memory in these things to put an Oracle database in. So it's not going to pull to it from a database everywhere. So it's actually going to store your data in a file. And that way, when you remember your SIM card, how many of you ever changed out phones? Got a new phone, and they take the SIM card and they move it to a new machine, and it imports all your data for your phone book over. That's because it's in a file that can be easily transferred. So there is good usefulness for this. And y'all are almost at the level now. Y'all can do the creation of the back end of that part. You're not ready for doing all the graphical interface yet. Trust me, y'all don't want to learn that part yet. Now get me in the fall with the Java class. We'll start doing some interface stuff, but you don't want to mess with that at this point. Trust me. Not in C. Java makes it a little easier, so that's why we're going to do stuff in Java later. So creating a phone book, what are we going to need? What data are we going to need?
Name. Number.
Okay, name, number,
Description.
description. What kind of description are you going to put on this?
Oh, trust me. Every time I'm horrible with names, so I'll put a little description of how I met them, why I got them,
So
all that shit.
this has got a blob field for you to type anything you want on. Now most phone apps don't give that to you, but that doesn't matter. It's not their phone app, it's our phone app. We're going to design it for what we want it to do. Then sell it to customers, whatever. This is why ours is better. Theirs doesn't give you this. Mine does. Now, name, number, description. You want to go ahead and store their addresses in here too, or at least their email addresses? Why not?
Facebook accounts.
Yeah, you can put any of those kind of things in there you want. All right. Name. Do we just want to put their whole name on one line? Or do we want it first name and last name separately? Giving the ability to sort by first name or sort by last name that way. We're not going to worry about sorting them today. That's beyond our range right now. But, so we can say, we'll do L name and F name. First name, last name, forget the middle initial, nobody cares about that, right? Only government forms and school stuff. All right. Sound good to you for a starter? You want to try multiple numbers for me? You want to have that ability. All right. So we're gonna. So you have like their cell, home, work. Ability for multiple numbers. So let's look at, we're going to do a struct. Oh, wait, type def struct. And remember that word first, or we won't know what you're talking about. All right, F name. What data type's F name going to be?
First name.
Remember,
Jar.
remember what we studied last time?
Array.
Now, here's a question for you. It's going to be an array of characters, also known as, what's a character array also known as? String. There, somebody was awake for the last lesson. So, how many characters do we want in their first name? What's normal?
Say 15.
15 is a pretty good number for it, because you get some weird people who run it off the board. People, maybe like who are our TAs for lab, stuff, and start writing their names out. Whoop, it won't fit in our fields. See, like one of them had problems while we had VJ to start with before Vivek came in. Is Vivek had trouble getting his Social Security card so they could work with us because the Social Security's computer system could not handle his name. So it threw it out. And they had to go through a manual process because it can't handle the big names. So it created all kind of issues for them and for us. I said, okay. And all it takes is because when they define the variable, when they define the thing, it was too small. And for the Social Security Administration to go back and change that, it's going to affect quite a bit of stuff. So you'd think they could work on that every once in a while. But okay, so we got our first name, I need the last name, so it's going to be pretty much the same thing. Last names tend to be a little bigger, so we will give them some more. Now, how many characters does this give us for the first name?
14.
This is 15.
Yeah, I didn't recall.
Exactly. Remember our end of line character? Our null at the end? Now take one off that number. That's what he said. But I declared 15, I tried to put 15 in and something's going wrong. Yeah, that's why. Number. Well, since we're going to have the ability to have multiple numbers, and those numbers can be different things, what if we do this? Type def struct. And we have I'm going to go ahead and make this a char for the number. Does that make sense? Character number. All right, how many do we need? Let's see, 903-7021-2222. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So give us 13 for a phone number. Don't forget our semicolons. Compiler won't like us. Why did I make the number a char? Because since it's a phone number, we're going to be putting dashes into it.
String.
Yeah. Since those are not numbers, they're better put this up that way. All right. Now, what else would we like to know about this kind of number? About the type. And it's going to be like 2 characters for that. So it gets that's their mobile number, that's their home number, their work number. There's something else we can do later once we learn enumerated data types. And we could also just make this an integer of a 1, 2, 3, and have some kind of table that looks up. A 1 is a home number, 2 is a mobile number. Yeah.
Why wouldn't you just do the number as a 10-digit number, but when it's put out, it would come out as that number formatted to include the spaces?
You're going to have to do some extra work. You have to take a number, change it into a string, parse off the first 3 digits, put a dash, parse off the next 3 digits, put a dash. Or we can just store it all here with our one-time read. Now, sometimes when you're inputting data into a website or something, you put the 903 and then it puts the dash automatically. Because it knows the format. It's a little bit more interactive, a little bit more coding. You would want to do that before you put this up on the App Store for people to buy. But you have to have a starting place. You get it working, and then go back and do those little tweaks. All right, so we're going to do that, and this is going to be our phone data type. So now, come over here, we're going to say phone. Data type phone, and the number, or what, how about phone type? I can say phone type, phone, there, that's better for me. And how many do you want the ability to save? We'll give them 5 of those. Nobody has more than 5 numbers, right? They won't be able to remember them if they do. We can change that later in the future if we need to. All right. Let's go ahead and give them the email next. Email, what's that going to be? What data type will we use for email? It's not going to be an int. It's not going to be a float. It's not a phone number.
Char.
Yeah, I'll make it another array here. And how long should our email address be? From my experience, you better take at least 50. You have like danny.morris2001 at patriots.uttyler.edu. Some of them are not, yeah, I don't like that, but some people have them, so you better give it. And we'll do the same thing with our Facebook. And
Same, it uses the email address.
yeah, go ahead and do that. Description. Oh, what are we going to do for description? It's going to be a char as well. And we can just give him some big old number here. 300. I'm going to give you 300 characters worth. That's more than Twitter gives you for a tweet. So that's the thing. Yeah, Twitter always has to. They just need to go ahead and change that number to something bigger and give you a little bit more space to send out a tweet, right? Ever tried to send much out through Twitter. You know, I never do Twitter. I don't really either, except for where I used to work. Where I used to work, I was the director of social media. And so my responsibility was to send the cafeteria menu out on Twitter each day. I hated Twitter. So I go to the person's email, copy it, go and paste it in. Of course, what was really bad on me is the person who would email me the menu would say things like, okay, hamburger, misspelled, green bean, and something. I said, oh, you only get one green bean? And what? And, or things plural that weren't supposed to be, and it's just, I got in trouble when I just cut and paste because I was in a hurry. Going, this is an educational institution. You don't need to be sending these things out to the public all misspelled and that. So. And I'd also have to, it would be like 3 letters too long, or a tweet.
That makes me laugh. There was a school on my way coming in here for like the last month. They finally took it down. The last month they had apparently they had some type of hamburger cookout, and on the sign it said hamburger. HAMBARGER. Hamburger.
Oh, oops. Yeah, West Memphis also in Plano. So I would do volunteer work with the police department up there, and so sometimes I'd go out and patrol a school zone at 7 o'clock in the morning, and I go sit out there and lock people up when they go too fast. They didn't know I couldn't give them a ticket. I didn't have that ability. Now, if they parked in a handicap zone, I could give them a ticket. It's like $250 if they parked in a handicap. I could do that. I had my little ticket book for that. But at school zones, you have to turn on the lights in the vehicle or whatever just to scare them. Yeah, one of these public schools, and the sign out front was all in Spanish. Like vacations coming up, whatever days. It's like, how are they supposed to be learning in an English school if all the signs are in Spanish? It won't help. So that's one of my pet peeves. Right?
Baby steps.
That's one of my pet peeves. We'll talk about the Walmart I went to in New Braunfels, where all the signage was only in Spanish inside the store. It's like, really? Anyway.
Learn Spanish, though. Most foreign language in the world.
Yeah. All right, so that's the end of our structure. This is going to be, we'll just call that an entry. How's that? Now, after you put what you're calling this data type, don't forget your semicolon. You need to say semicolon after you create that. So important parts. Type def, struct, open your things, define it, give it a name, and a semicolon.
Is this all done outside of the main?
Yes, it's outside of the main. A lot of times we'll actually move this over into a header file. We'll get to that part later. You can do it in your main, but if you're going to be reusing, move to a header file. Okay, we'll probably work on that part next week. So, how about some code? No, cancel that. So if y'all want, go ahead and pull up a Visual Studio.
This kind of stuff that we would need to know to work throughout 8.
Nah. This week's lab, coming up, Thursday. We're going to take what we've been doing and translate it into this. So, let's see, we're going to go do a new project. And, see, 132, console application, new name. Sounds good to me. Application settings. Also application MP project. Finish. Eventually we'll get there. Alright, source files. Let's go over here and say we're going to add a new item. C++ file. Book.c. Alright, here we go. First thing you need. Include stdio.h. That's always a good one to put in there, right? Define max entry. Oh, we're going to learn how to do it in Git. For now. I can grow that later. Okay. We want to def us. We said we need, actually, if we're going to use this within that guy, we need to define this guy first. Or the other guy won't know who he is. So we're going to do a char number, 13 of those, char type, 10 characters long, and him. Alright, just that easy. Cool. We're going to be playing with some strings, so we better come up here and also kind of include string.h. Pretty silly thing. One thing I don't like about these sometimes is you open a quote, it closes a quote. But you would need to put stuff in. And it, yeah. And type def struct. Hopefully y'all are working along with me on this part, because this is how you get better at remembering what to do. It's because you're actually doing it. Okay. Char f name. And that's going to be 15 characters, including the null character. Char l name. I give them 20. Okay. Oops. Facebook. So 50. Our descriptions of 300. And is of type entry. Now, we've got our new data types declared right there. Now we're going to come over here and we're going to have void main. And we go back and make this void right with no end in it. Alright. First things first, we're going to want to set up entries. Entry. List sub max entry. That because I had my caps all up here. Define is lowercase. That should, yeah, that fixed that. What did I just do? Right here. Y'all see that? Make it a little bit bigger for you. What does this line do?
It opens an entry, calls list, and sets an array for 250. Maximum
Actually,
phone list.
I'm going to have an array called list of type entry. That's this guy right here. So we have max entry. Up top said max entry was 250. So that's giving me a list of 250 entries. We're going to call that, that's, the name is list. All right, so what am I going to do with it? I need to populate that sucker, don't I?
What's that phone type?
Hmm?
Phone type.
Phone type?
Yep. Another one we got to find as well.
Is that? Oh. Here it is.
Gotcha.
There we go. Oh yeah, we got him. But yeah, if you just saw him in there, you're like, huh? Now if I didn't have him up here, he would light up bad down here. So I don't know.
Yeah, that's worth it. Might as well like that.
So. Alright, we're going to need to populate him. So this is where we can do a thing of, okay. Char. That's what we're going to call him. Once again, this is the hard part. Selection. How about char selection? Selection. F. Equals menu. That's bad. Now we're going to come down here. And I'm going to have char. Better yet, see, that's how you actually do some programming. If you're thinking on the fly with it, you're going to be bouncing back and forth. So, I'm going to create a menu function. We can call it anytime we want. This is just a your selection. New line. One. And tree. function called menu. This is where it's going to write the menu each time. This is where it's going to print the menu. Print the whole book. And yeah. What else I want to do? Now I can put a command in and clear the screen each time too, if you really want to do that. So we'll worry about that part later. Alright, so back up here to the main. Okay, we're going to go down, we're going to do the menu while selection not equal to, what was it? 3? That needs to be in use. We're going to do our other stuff. The last thing of the while loop, we will repeat this command. So that we show the menu and check again. Alright. Now, we're going to do a case switch on selection. Case 1. And we can call a function to add entry. Break. Case 2. And see how this builds upon everything you've learned before. You can't just sit down and run a program using our new commands. You're still going to use all the commands you've ever done before. Print entry. Print list. Actually, I have to pass the list. Pass the list. Break. Yeah. Alright, so this keeps our main nice and simple. We show the menu, and then we do stuff based off of the menu, and then we show the menu again, and we keep doing that until they pick something different. So the main is nice and simple. Now we gotta go back and create add entry and print list. Guess what? Add entry is, we're going to need to declare him up here. And it's going to be void. Huh?
Type it too fast.
Sorry, that's one thing you get used to when you. It's better than my writing on the board anyway. You can actually read it on the screen. Okay, void. What we're going to do here, that's the add entry. Bringing in an array of type entry. This is the prototypes. List entry array as well. So more functions. Alright, we're going to have void add entry. You can bring in entry, and we'll keep referring to them as list. And then colors. Alright. Now we are going to, what else we need to do with this? Kind of need to know how many we already have, so we also want to keep them integer. It can hold 250. We're not going to start with 250, are we? We don't sit there and print a bunch of things that don't exist yet, so. And we have no entries, you can see. Add entry, we're going to come in here, say list, comma, get back and forth a little bit with this. Now, when we come back from adding an entry, what do we need to do? We kind of need to add one to no entries, because we will have a new entry added. So we're going to increase him so that we will know how we got. Okay, now we skip back down here to add entry. You're getting how my brain works.
You're just going to post this, right?
Huh?
You're just going to post this later, right?
Yeah, this will be posted, but once again, you're seeing how the brain flows through as you're writing a program. So that's part. So you don't always sit there and write it start to finish. You're going to be skipping back and forth. Okay, once I got down in this function, I needed something else I didn't have before. I didn't think about that part earlier, because I didn't have to worry about that yet. But as soon as I came up with, okay, I need this to get this to work, go back and add it up here so that I will have that piece when I need it. And that's the way, once again, that's the way your brain will work. It might seem a little screwball when it's somebody else's brain, but and everyone else's brain works differently as well. You might have a different thing you do, but you're seeing my brain work on the fly here to create this. And I did this intentionally so that you can see what process we go through to create something like this. I could have already had it all done up and say, oh, here it is. This is what does this. But you're not seeing the process. And that is the most important part of the engineering function, creating. So, understand all that? Yeah. Otherwise, you see how sometimes it kind of seems a little ADD, but there's a method to it. All right, so now we're going to add an entry. And say, okay, we're going to be doing a bunch of printfs and scanfs. So we want to printf, and we want the first name.
You got to do the open quote.
There's the other one over here. First name. Percent. No, don't want to put anything else there. Yeah. Okay, scanf. We're going to come down here and say is percent S.
Name.
Okay.
wanna say percent 15?
Actually, we are bringing in list. We already have list. So he's gonna be going into list, sub, no entries, dot. Oh, that says it is. It's a string going in there. So that's F name. Since we're writing into a string, did we determine we did not need the address operator? I think we determined we didn't do that, didn't we? That's one of those little tricky things. We can go back and fix that later if we have to. But notice, that's one of those questions that comes up that if it doesn't work, we know where to go again. That's part of the debugging. Now, continue on. Last name. That's going to go into his L name field. Now, once again, I am pulling those little fields off of here. You can call these members or fields, whichever subpart of the structure we're looking at. All right, next item. Let's get the phone number. Oh wait, there's going to be multiples of those.
Column type. This would be our phone. Wow, what did we do there? 5 fingers. Is it called phone? Oh, no, that would be phone. Yeah. Phone. Sub. X. 0. That now, so, okay, and that is 0 dot number. And we got phone 0, so number. I understand those 2 lines? What we're doing with that? And then you gotta do X plus plus. X is less than 6. Or less than 5. No.
Let's see.
0, 1, 2, 3, 4. Oh, X is less than 5.
Wow, this, upon our streams we were playing with. What's this saying? So we're going to do this while string length of the phone number we just entered is greater than 1. And we get to here and I just hit enter, enter. Yeah, I just want one phone number. I just enter one number and then come back and hit enter, enter, and it skipped out.
But on your type def struct,
Yeah, they can have
types
up
can
to
have
5.
5.
But we don't want to sit there and prompt them. No, you got to have 5. We've got room to store 5. But,
So you say greater than 1, but less than 5.
complex math and this is 5.
Just less than. You get 0 through 4. I'll give you 5 entries.
So it's already incremented it. So 0, 1, 2, 3,
Okay.
1 is 4. I incremented 5, and if it's equal to 5,
So do's going to do it
Actually-
out of the way, so it's going to come into it as 0.
yeah, actually if it goes to 5, we're going to knock it out.
Okay.
So yeah, as long as it's as it's less than 5, we will keep going. All right. That's because we got to let them have multiple phone numbers. That's why we had to have a little complex stuff in there. All right. Go back. Got 3 more guys to handle here real quick. And that is his email, Facebook, and description. All right. And we will return. And read him in. All right, we're going to come up here. Click this. Go ahead. Click this. And he's going to be in the tree. This just like the last guy. And right now, we'll have time to do him today. Save, build, see if we can do anything. See what errors I get in here. Fell, why?
What's the scope of it?
I thought I missed a colon right there, and a colon right there. Okay, now maybe a few more things, we'll hold up.
You didn't close your
Gotta close
target.
that guy. It happens to me too, so I'm not the only one who have some issues sometimes with these things.
not trying to put a computer up for your window.
Come on. Here. Pass for all those guys. I don't see one of them.
A wall. Go to your wall. You misspelled wall.
There?
No. You look on your list down there. At the bottom, showing your errors. Right there.
I had missed a semicolon above it. That's one thing, if you miss a semicolon somewhere up there, you can't always trust it from that point on. That helps too, okay. First get x equals 0, x plus what is saying? Up top. Sometimes it gets picky on that, it shouldn't, but something is set. Main informal parameter list for legal. Oh. All right, now maybe we can do better. Succeeded, yay, it finally worked, okay. Debug, start debug. Alright, so there's our part, make a selection. 1, 2, or 3, I'm gonna do a 1, first name, Morris. 3 dash, 1, dash. I'm not giving you my real number, type,
But you narrowed it down to 1,000 for us.
yeah. It didn't like my spaces. Just hitting enter, I put something in that prevents it from accepting that. So that's something that we would go back and change. That's part of what debugging reasons for. Just trying to be a safety kind of thing and it's go right up.
Good thing you decided to put that block in there like I told you.
Yeah, see, it was because I put.
You would have had an infinite loop,
Yeah, that's what Control C gets you out of that.
but you wouldn't be able to finish.
Okay, description. Blah, blah, blah. Oh, now what's it doing?
Now you got an
Now we
infinite
got
loop.
it. That's not reason. Control C. Oh, well, I was hoping to show you the memory stuff, but I guess we'll continue that next time. We've got our file and we see it's got some issues, some little things of logic that needs corrected in there, so we'll get that once again next time.